everybody, this is Dr. Nigro with the Chem Calculations video. The screencast is going to look at writing net ionic equations. All right, so a net ionic equation is exactly what it sounds like. We're going to take what is basically a double replacement reaction, and we're going to break those reactants and products into our separate ions. So we need that double replacement reaction. And it doesn't have to be a double replacement. That's going to be most of our examples, but you can easily write net ionic equations for other types of reactions that involve ionic compounds or acids. All right, we are going to focus on double replacement, but I don't want you to think that's all you can do. All right, so to write a net ionic equation, the first thing you need is a balanced chemical equation. So we got to start there. That means if you're given the compound names, you need to convert those into formulas. You need to include the states, and then you need to balance. So we need a balanced chemical equation. Once you have that, you're going to split your AQ substances, so our substances that are solutions. Whoops, sorry, I wrote that wrong. Substances into their ions. And remember that these can be our ionic compounds, or we might have some acids involved. All right, but they will have this aqueous designation. If it doesn't have an aqueous designation, you cannot split it into its ions, because when you dissolve something that's not aqueous, it doesn't split into ions. That's what the aqueous means. All right, and then finally, you're going to ID your spectator ion or ions. All right, so a spectator ion we're going to see is something that shows up on both sides of the arrow. So it'll be on the reactant side and the product side, which means that it doesn't actually participate in the reaction that it's occurring. It's just spectating. All right, and I'll show you what that looks like as well. All right, so you're going to cancel those, and then you're going to write what remains. All right, so the remaining reactants and products. All right, at that point, it should be balanced already. And that balancing should be by atom and by charge. All right, so these are really easy to check. So when you're finished, if they aren't balanced by charge and atoms, then we've done something wrong somewhere up in the problem. We need to go back and check. All right, so let's try a couple of these. All right, so for our first one, we've got aqueous sodium iodide mixed with aqueous silver nitrate. Right, the balanced chemical equation and then the net ionic equation. All right, so we start with sodium iodide. All right, so sodium iodide, sodium's +1, iodide's -1, so we get NaI. We put our aqueous state. All right, then we've got silver nitrate. Silver's +1, nitrate's -1, so we get AgNO3, and that is also aqueous. So there are reactants. All right, I have two ionic compounds, so it's double replacement. So the sodium and the nitrate are going to come together and form a compound. All right, and if I go check the solubility rules, I see that all compounds containing a group 1 metal or all compounds containing nitrate will be soluble, so it remains aqueous. And then when silver comes into contact with iodine, similar to when it comes into contact with chloride, it forms a precipitate. So we have a solid that forms here. All right, we check for balancing. Everything's balanced as written. So this is our balanced chemical equation. All right. So what we're going to do now is take each compound on the reactant and the product side, and we're going to split them into their ions. Now, if you have a coefficient out front, you need to have that many ions in your, what we call, I don't know, not net ionic yet, but our first ionic equation. All right, so I'm going to start with sodium iodide. So that means I have a sodium ion, which is in solution, and I have an iodide anion, which is in solution. All right, I look at my second reactant. I've got a silver ion, which is in solution, and I have a nitrate ion, which is in solution. All right, so I've split all of my reactant molecules into their ions, and the number of ions I'm showing are equal to the number of atoms I had in the balanced reaction on the reactant side. All right, now we switch over to our product side. All right, I have an aqueous solution again, so I'm going to split that into sodium ions and nitrate ions. All right, then I come to my second product, silver iodide, which is a solid. So that means I just leave it alone. I just rewrite it as is, so AgI. All right. Now I'm going to look for spectator ions. All right, so a spectator ion is something that shows up on both sides of the arrow and looks exactly the same. So if you look, I've got a sodium ion here and a sodium ion here. So they're going to cancel. So that makes sodium one of my spectator ions. All right, I have an iodide ion on the reactant side, but none on the product side. I have a silver ion on the reactant side, but none on the product side. I have a nitrate ion on the reactant side and a nitrate ion on the product side. So there's a second spectator ion. All right, I then look and see what's left, and that is going to be my net ionic equation. So I have an iodide ion plus a silver ion reacting together to form solid silver, that's aqueous, solid silver iodide. So this is going to be my final net ionic equation. All right, the spectator ions are going to be your sodium ion and your nitrate ion. Okay? All right, so let's try another one. Let's come down to number 2. All right, here we have a solution of potassium bromide mixed with a solution of ammonium nitrate. Write the balanced chemical equation and the net ionic equation for this reaction. All right, so we start out by writing KBr for our potassium bromide, and that's going to be aqueous. And we're going to add to that ammonium, NH4 nitrate, NO3, that's +1 and -1. Again, aqueous. And we're going to run a double replacement reaction. All right, in this case, the potassium is going to interact with the nitrate, so we get KNO3. All right, potassium is again a group 1 metal, so it's going to be aqueous. And then we get ammonium interacting with bromide, so NH4Br. And if we look at our solubility rules, compounds that contain ammonium are also always soluble, so that's also aqueous. All right, so in this case, both products are aqueous. All right, so we have no visible product forming here. So what we would say in this case is that there is no reaction occurring. All right, now does that mean that they don't split into their ions? No. All right, they split into their ions, but if I were to write out the ions of all of these reactants and products, everything would cancel. So it's considered a no reaction. So whenever you get both products as aqueous, just keep in mind that if we can't see the reaction occurring, then there's no reaction. So remember, you got to have a solid form. All right, you can watch out for pure water forming because that's a liquid, which is a state change, or gas formation. All right, that gas formation happens quite a bit when we have carbonate compounds. Okay, so those are just 2 examples of how to write net ionic equations.